Okay, Abraham, you can start.
Just give me a minute. I'm just presenting it. It had gotten cast. Yeah, okay, I can see it.
It's visible, Abraham.
Okay, ma'am. Abraham, click present on the top. Actually, Emma, I'm using another laptop. Okay. Finding it difficult to find out where everything goes. Now, can you all see? I can see your presentation, but you're not like done now. Yeah, now. Now it's black. Now it's black.
Now it's visible again.
Giving slides. Okay, so mom, can you see now?
Yeah, now it's right.
I'm sorry. Ma'am, it took so much of time, ma'am. I tried it earlier, but at that time it happened.
Okay. It's okay, Abraham. You can move on now.
Wait, ma'am, 1 minute. Just I can note down. Yes, ma'am. So today I'm going to talk about chemistry. Today I'm going to talk about chemistry. So basically, first we're going to start with atoms. So what is an atom? An atom is basically the building blocks of the universe. Okay, so an atom is the so every atom has three main parts: a proton, a neutron, and an electron. The electrons spin around the nucleus, which composes of protons and neutrons. Neutron. So for this, we're going to watch a small clip to better understand this. Is it audible?
It's not audible. You have to turn on audio sharing.
Yes, ma'am, I'm turning that on.
What is an atom made of? Let us just pretend that atoms look like this for a minute to make it easier to understand. An atom consists of three elementary particles: neutrons, protons, and electrons. Protons and neutrons bind together and form the atom core, held together by the strong interaction, one of the four fundamental forces in the universe. They are made from quarks and held together by gluons. Nobody knows exactly how small quarks are. We think they might literally be points, like in geometry. Try to imagine them as being zero-dimensional. We suspect that quarks and electrons are the most fundamental components of matter in the universe. Electrons orbit the atom core. They travel at a speed of about 2,200 kilometers per second, fast enough to get around the Earth in just over 18 seconds. Like quarks, we think electrons are fundamental particles. 99.9999999.
Abraham, you're not audible.
So now you didn't hear the video.
No, the video was audible, but your voice was muted before. Now
So,
we can.
so now we are going to learn, now that we understood about the atom. So the atom, now to better understand the atom, we need to know that there are different types of atoms. So these different types of atoms are called elements. So now let's talk about elements. So what are elements? So elements are the substances which only one type of atom, meaning that they have the similar type of proton, the similar type of not proton, but the same amount of protons, the same amount of neutrons, and the same amount of electrons. If any three of these quantities are different, then both the elements are not the same. Now we are going to understand about the periodic table. So what is the periodic table? The periodic table is the way we organize all the known elements into certain categories. So the elements are organized by their atomic number. An atomic number is the number of electrons, and this is also the same number for the number of protons. Both the numbers are same. Normally it's not given here, but normally you would have another number called a mass number. This number could be the amount of neutrons and protons. So sometimes you may find this number to be in points in the periodic table. The reason the mass number is in points is because because of the various isotopes of the element. So I'm not going to get into isotopes, but now we will understand the history of the periodic table. So people knew elements, but for the elements to be classified, there was a full history. Okay, let's take a short quiz. Do you know how many elements are there in the periodic table? Anybody can just answer. Anybody knows how many elements are there in the periodic table?
Are there 56?
Too much. Not 156.
118.
Correct. So now I'm going to watch this video. So just to get you started, this entire periodic table you can see on this on my screen. It's actually before this guy came, Mendeleev, who invented the periodic table, the current one, and was perfected by Henry. This was the table that was going, and the many wrong things were that it didn't contain the full 118 elements. Number one, number number two, number two, that some columns didn't react with each other, and some even were placed in the same column, like placed in the same category, even though they were not reactive with each other or didn't even react like the other. Okay, so we're gonna watch this video.
It eventually broke down and made some elements
Yeah,
being
you
grouped
can
together despite not having
put it
similar
to full
properties. Then came Dmitry Mendeleev, Russian chemist, who looked at the periodic table that was being used at this time.
Okay, you want me to put it to full screen?
Yes.
Now can everybody see?
Yes, it's perfect.
Having similar properties. Then came Dmitry Mendeleev, Russian chemist, who looked at the periodic table that was being used at this time. He noticed a few problems in it. Some elements were being put into groups with other elements, which they did not react similarly to. And some boxes of the periodic table were even having multiple elements put into it. Mendeleev started writing each known element on cards and kept rearranging them like playing cards. After relentless work, he fell asleep, and instead of getting nightmares, he got the idea about how his periodic table should work. Mendeleev took the elements that are problematic and placed them into the groups that share similar properties, whilst making sure to keep one element in each box. This ended up leaving gaps in the periodic table that could be filled in by elements that were found later by other scientists. This was one of the main reasons his theory was so readily accepted, and in fact, his design led him to obtain the nickname the father of the periodic table. The other reason his theory was accepted was that the discovery of isotopes showed that we could not base the classification of the elements on the atomic masses alone, like the previous scientists had done. This was improved better by young Henry Moseley, who deduced that the periodic table is best arranged based on its atomic number instead of its atomic weight. You can learn more about isotopes in our other video. Today's periodic table of elements is an updated version of Mendeleev's design. Each element is given a square in the table that tells us its name, its chemical symbol, its atomic number, the number of protons, and its atomic mass, the number of protons and neutrons, based on its isotope abundance. These elements are listed in order of increasing atomic number and are organized into groups, which are the vertical columns, and periods, which are the horizontal rows. Elements that were put into the same group were put there because they reacted similarly to other elements in that group. And although this wasn't known at the time, this was because the elements in the same group had the same number of electrons on the outer shell. You see how Mendeleev
Unmute yourself, Abraham.
So did you all understand about what the video was trying to say? If you all have any questions, you all can ask me.
Yeah, understood.
So Emma, what is your question?
I don't have a question. I said that was really easy. Understand. Like I understood it.
Yeah, me too. I also understand.
Okay. Now we're going to go back to the PPT. Okay, now just to understand a little bit about the periodic table, we are going to visit. So can you see this table of elements? Can you see this is the periodic table. Okay.
Yeah, I can see.
Okay, so this column that's over here from 58 to 71, this entire blue thing will come over here. Okay. And then from 30 all the way till 103 will come over here. So because the periodic table would get normally too long, they put it down. So in this we can see that the atomic, so see, what you can see is we have number 1, which is our atomic number, and then this is the mass number. The mass number will mostly be in points is because of its isotopes. So now hydrogen actually goes over here, but over here in the over here, but like it goes above over here. So they kept it over here in order to balance it. So we're going to first start with this row. This is called alkali metals. Okay, I'm not going to say, I will say little about the properties, but I won't say much about them. So then next we have alkaline earth metals. So both of these are metals, but they just have a few different properties. After that, you see this entire purple. These are called transition metals. In this, it includes iron, cobalt, nickel, copper, zinc. So, metals that are mainly hard. Okay. None of these are radioactive. Then, so you can see this is lanthanide and anthracite. So, this is the lanthanide. From year to year, these metals are all this is the anthracite. These all metals are radioactive, and the lanthanide are like kind of like a normal metal. Then you have the unknown properties. So some properties in the periodic table we don't know because these elements are very unstable. So what happens is with an unstable element, we cannot come to know their properties. It includes orgasium, the 118th element. Then we have post-transition metals. So these are like metals, but I could say maybe they're a little softer or they're liquid. Then we have this one, metalloids. Why are they called metalloids is because this entire yellow column, it has properties like metals, but they are not metals, such as silicon. Silicon has properties like metal, like it meaning it is a solid and it's pretty strong. But unlike a metal, it is not malleable. That's what I think. Then we have reactive non-metals. So all of these non-metals in the blue are very reactive. And last but not least, we have noble gases. These gases, like such as them, they are not that reactive as the reactive non-metals. So now that we understood about the periodic table, we are going to go back to the PPT. Okay. And then I'm going to explain what are exothermic and endothermic reactions. So these are mainly two types of reactions that happen in so these are two types of reactions that happen: exothermic and endothermic. Endothermic reactions are reactions that are the so we'll first talk about endothermic. So a quick quiz. Does anybody know what is exothermic or endothermic? If you know, you can share. Anybody, you can just unmute and say. Okay, a quick hint. Exothermic is when the reaction is a little bit hotter, and endothermic is when the reaction is a little bit cold. Becca ma'am, you can also try. Okay, I'll explain this.
Okay. All right. So exothermic reactions are the reactions um, that when they take place, they release heat and energy into the surroundings. And endothermic reactions are kind of the opposite of it. They absorb heat from the surroundings. Exothermic reactions can be combustion, okay, it can be oxidation, and endothermic reactions can be decomposition reaction or photosynthesis reaction.
Yes, ma'am. So I'll just talk a little more about it. Exothermic reaction is when two reactants substances form together, when they combine, like combustion, it creates a lot of heat that ma'am already explained. This heat energy is taken from the reaction and it's giving out to the surroundings. That's why when this reaction is there, and if you put a thermometer, the temperature will start to rise. Then endothermic reactions. These reactions are reactions which the temperature drops. The problem is we need to understand how the temperature drops. So, since heat energy is a type of energy, what the particles do is they take the heat energy in an endothermic reaction and they store it in chemical bonds. That's why the temperature drops because they have taken all the heat energy from the surroundings. Then another yeah. Then so just a fun fact, did you know when you eat sherbet sweets, it actually performs an endothermic reaction between hydrogen carbonate and citric acid that is mixed in the sweets, but it doesn't happen until unless it dissolves in your saliva. That's why you feel a cool fizzy feeling. And thank you for listening to my presentation. Thank you, ma'am.
Okay, good, Abraham. Now we will move on to Emma's presentation. Unmute and say Emma.
Ma'am, I just said that I'll just share it 1 second.
Yes, yes.
Ma'am, can you all see?
Yes, Emma, it's possible.
Yes, Emma. Okay. Okay. Types of change. So this is the content. We will have natural and man-made, periodic and non-periodic, reversible and irreversible, physical and chemical, biological, slow and fast, natural and man-made changes. Natural changes refer to alterations in the environment caused by natural processes like weathering, erosion, and volcanic eruptions. These changes shape landscapes, affect ecosystems, and occur over time without human intervention, reminding us of nature's power and constant evolution. Man made changes refer to alterations in the environment resulting from human activities. These can include urban development, pollution, deforestation, and climate change. Understanding these impacts help us realize the importance of responsible actions to protect our planet from for future generations. Similarities and differences. Natural and man made changes both reshape our environment. They can affect ecosystems, influence weather patterns, and alter landscapes. While natural changes occur gradually, human actions can rapidly impact the same area, showing how interconnected our world truly is. Differences. Natural changes occur through natural processes like erosion or climate shift and are often gradual. In contrast, man made changes are intentional actions such as urban development or pollution, which can happen rapidly. Understanding these differences help us grasp our impact on the environment. Periodic and non-periodic changes. Periodic changes. Periodic changes occur on at regular intervals like the seasons or lunar phases. These can these changes can predict and help us plan activities. Understanding periodic changes is essential for recognizing patterns in nature and daily life, making it easier to adapt to and anticipate what's ahead. Non-periodic changes. Non-periodic changes occur irregularly without a schedule. Examples include natural disasters, economic shifts, and or sudden technological advancements. Understanding these changes is crucial for adapting to life surprises and making informed decisions in an ever evolving world. Effects on the environment. Periodic changes like seasonal shifts affect ecosystems and can enhance biodiversity. Non periodic changes, such as natural disasters, disrupt habit and can lead to species decline. Understanding these impacts help us appreciate our environment and encourage responsible actions to protect it. Periodic changes occur regularly, like season shifts, requiring humans to adapt to their activities, such as farming or, and clothing. Non periodic changes like climate change or natural disasters dem- demand immediate and sometimes drastic adaptation to ensure survival and community resilience. Understanding both help us to prepare for our future. Reversible and irreversible changes. Irreversible changes. Irreversible changes are transformative where the original material cannot be restored to its initial state. Common examples include burning wood, cooking an egg, or rusting iron. These changes often create new substances, making them permanent and unchangeable. Understanding these help us grasp real world processes better. Reversible changes. Reversible changes are alterations that can be undone, restored to the original state. Examples include melting ice, boiling water, or inflating a balloon. These changes highlight how matter can easily shift forms without permanent transformative transformation, making them easy to observe and understand in everyday life. Reversible changes are those that can be undone, like melting ice back into water. For example, in a case study of ice cream making, students observe how heat changes the ingredients, but once cooled, it transforms back into the original creamy state, illustrating a fun practical example of reversible changes. Irreversible changes, like baking a cake, shows how substances transform permanently. In a case study, we explore how heat alters ingredients, creating new flavors and textures that can't be undone. This highlights the importance of understanding change in everyday life and science. Physical and chemical changes. Physical changes involve alterations in the form of appearance of a substance without changing its chemical identity. Examples include melting ice, dissolving sugar in water, or tearing paper. These changes are often reversible, making them easy to observe and understand in everyday life. Chemical changes. Chemical changes occur when substances transform into new materials with different properties. These processes involve breaking and forming chemical bonds, often accompanied by energy changes, color shifts, or gas production. Understanding these changes help us grasp everyday reactions to rusting or baking. Nana. One
Okay.
second. No, wait. It was there was by mistake two slides. There was
Okay.
by mistakenly two slides.
Okay. So you want to continue, Emma?
Yes, ma'am.
Continue.
Right. Physical changes involve alterations in form or appearance without changing the substance itself, like melting ice. Chemical changes create new substances through reactions like rusting. Understanding these differences help you analyze everyday transformations, reinforcing your scientific knowledge. Periodic and chemical changes have unique impacts on society. Physical changes like melting ice affect weather patterns and ecosystems, while chemical changes such as combustion play a vital role in energy production. Understanding these differences help us make informed choices that protect our environment and health. Types of biological changes. Biological changes refer to alterations in living organisms over time. These can be genetic changes such as multiplication or physical changes like growing and develop. Environmental factors like climate change can also impact species adaptation, leading to biodiversity shift. Understanding these changes is crucial for protecting our planet's ecosystem. Biological changes occur through processes like growing, development, and aging. These changes are driven by genetics, environment, and biological systems. For instance, hormones influence puberty, while nutrition affects physical growth, showcasing how interconnected and a dynamic life process truly are. Evolutionary changes refer to the gradual development of a species over time through genetics, various and natural actions. These changes help species adapt it to their environment, leading to diverse forms of life, like how the prepper moth changed color to survive pollution. Human activities like deforestation and pollution drastically impact ecosystems. These changes can lead to habit loss and species extinction, disrupting food chains and biodiversity. Understanding these effects emphasizes the importance of conservation and responsible environmental practices for a healthy planet. Slow and fast changes. Slow changes happen gradually over time, often going unnoticed until their accumulation significantly. Examples include climate change or slow shifts in culture norms. Understanding these changes help us appreciate the importance of patience and perseverance in making a positive impact on our environment and society. Fast changes occur quickly uh, and often catching people off guard. They can be exciting like new technology or trends, but can also challenge the to adapt. Embracing fast changes teaches resilience and flexibility skills. These are essential for navigating life's ups and downs. Slow changes like climate shift, gradual alterations in environment, say, they can lead to species decline, habitat loss, and disruption in ecosystems. Understanding these impacts help us appreciate the importance of conservation and our role to protect nature. Every small action counts. Fast changes like natural disasters or human activities can drastically harm our environments. They lead to habitat destruction, pollution, and loss of biodiversity, disruption ecosystems, and making it harder for planet and plants and animals to survive. Understanding these impacts help us protect our planet. Thank you.
Okay. Good, Emma. Anna, hope you're ready now. Unmute yourself, Anna. Turn on your video. Yes, Anna. Unmute yourself.
Yes, ma'am.
Yes, and turn on your video.
Ma'am, I'm doing the presentation on an iPad, so when I present, it doesn't let me switch on my camera.
Okay, so you are using only one device?
Yes, ma'am.
Okay. All right. No problem.
Um, can you see my screen?
Yes, it's visible. it also.
Answer.
Can you go back to the slide once?
It's really fast, so you can't really read it easily.
Can you go back to the slide once again, Anna? Anna, can you hear?
Yes, ma'am.
Can you reshare the slide once again?
Yes, ma'am. Are you able to read it, ma'am?
No, Anna, it's not visible.
Is it visible now?
Yes, it's visible now. Can you go to the slide where the plants and animals?
This one, ma'am?
No, not the quiz. The meaning of plant and animals. Yes. Now, can you explain it?
Yeah. So an animal cell is a type of bureaucratic cell that makes up the tissues and organs of an animal. But unlike the plant cell, animal cells do not have a cell wall or a chloroplast. But they contain specialized structures called organelles, which makes up the animal cell. While on the other hand, the plant cell is the basic structural and functional unit of plants. It is a eukaryotic cell, meaning it has nucleus and membrane-bound organelles. These organelles allow plants to grow, produce their own food, and maintain stability.
Okay. Now, can you go over the parts of the cells? Parts of plant cells and animal cells that you've included in the presentation?
Yes, ma'am.
One by Anna, I am explaining to this slide, and explain. Okay?
Okay,
Not
ma'am.
the. Yes.
Okay. Okay. So the nucleus of the animal cell contains DNA, which carries the instructions for all cell activities. And the nucleus in the plant cell also contains a DNA which carries the instructions for all activities. Um, they both have mitochondria. Mitochondria is the is the powerhouse of the cell, produced energy through cellular respiration by breaking down glucose. And then they have ribosomes, which produce proteins which are essential for cell growth, repair, and function. And the Golgi apparatus modifies, sorts, and packages proteins and liquids for storage or transport. And vacuole is like a storage unit or warehouse. It keeps extra supplies and waste until the end. And then the plasma membrane, which controls what enters and exits the cell, maintaining homeostasis, provides protection and structural support.
Okay. Yes, Anna, you can proceed with the quiz now.
Okay. Anyone is free to answer, okay? Okay. So the instructions are you have to identify the parts of a plant cell based on the provided descriptions, and you should write your answer in your on your answer sheet. If you don't, you just have to just say the answer. Okay, the first question. This round organelle is the center of the cell. It controls all the activities of the animal cell. Does anyone know what it is?
Abraham, Emma, Nathaniel.
Nucleus?
Nucleus?
Yes, it's the nucleus. Okay. The next question is what organelles help break down certain materials inside the cell? It's fine if you don't know the answer because I have added some extra cell organelles of the plant and animals.
Mitochondria.
No, the answer is lysosome, but good try. The next question, what is the part that helps process and package proteins and lipid molecules in the animal cell?
Ribosomes?
The answer is Golgi apparatus. Which rod-shaped organelle can be deemed as the cell's powerhouse?
Mitochondria.
Yes, correct. Okay. What part of the animal cell is responsible for producing proteins that the rest of the cell needs to function? This component can be either smooth or rough in texture.
Is it like the leaf? Oh, wait.
It's not a leaf. It's an organelle of the plant cell.
Okay, okay.
Is it is it a Ribosome.
No, it's not the ribosome. Okay, I'll show you the answer. It's endophysic reticulum. Okay, what part of the cell separates the interior of the cell from the outside environment and controls the movement of materials in and out of the cell?
Cell membrane.
Yes, correct. Last question. Which specific part of a plant cell is responsible for regulating water balance?
Is it the nucleus?
No, I'll give you.
Wait, sap vacuole.
Yes,
Vacuum.
thank you.
Okay. Good, Anna, and good all of y'all for answering. Good tries. Okay, so we will stop here for today. And tomorrow we will review. Okay, tomorrow I'm going to discuss and review your presentations. Okay, and regular class we'll have for science and maths tomorrow. All right.
Ma'am,
Well
should
done.
we send your PPTs or like?
You can send me the PPT. Okay, you can put it in the group, the presentations. You can, all three of you can put it in the group, Abraham, Anna, and Emma. Okay. Tomorrow we will meet at regular timing for our science class and maths class. And in the science class itself, I'm going to review your presentations individually. Okay. Okay. All right. Have a good day. See you all. Bye.
Bye,
Bye, ma'am. Thank you.
Okay.